we're going to look at some expressions where we have a square root in the denominator. And we don't consider that simplified in the math world. While it's, just fine that it's actually a number, in days long ago before there were calculators that could do functions like this, it was just easier to have a non-irrational number in the denominator. So we're going to practice rationalizing, or pretty much just getting the radical out of the denominator. So in order to do that, we need to somehow get rid of this square root of 3. And the only way to undo a square root that we know is to square something. But I just can't square and square. That's not going to be keeping the problem the same. So what I'm going to do is multiply the numerator and the denominator by the square root of 3. And we know that if we have the square root of something and we square it or multiply it by itself, then we actually get what's inside. The square root of 3 squared. Well, those are inverse operations, so we just get 3 as an answer. So by doing that and multiplying across, I get 1 times the square root of 3. And then I have the square root of 3 squared. So in the numerator, I just have square root of 3. And then the denominator, I have 3. And that's as far as we need to go. The denominator no longer has a radical in it, and that's kind of what we wanted to rationalize. All right, let's look at number 2. And when I look at number 2, I look at the denominator, and I see that there's a square root of 2 in the denominator. So since that's the part that I'd like to get out, we're going to multiply the numerator and denominator by the square root of 2. And by multiplying by the square root of 2 over the square root of 2, it's really like I'm multiplying by 1. It's just a fancy 1. And let's go ahead and see what we get when we multiply the top. Now, because 3 isn't in a square root, we can't combine it with that, so it stays outside. So I have 3 square roots of 2 over 2. And then right here, I'm going to get the square root of 2 squared, which is really just 2. And then I'm going to simplify even more. 3 square root of 2 over 4. So that's rationalizing the denominator. Let's look at something a little more difficult. We could also be presented at the end with the square root of a fraction. And one of the properties of radicals is that if you have a square root of a fraction, you can split it and take the square root of the numerator and put it over the square root of the denominator. And let's just simplify this because I see the square root of 4. And the square root of 4 is 2. But now I'm left with this square root in the denominator. So to get rid of our square root in the denominator, we multiply by a fancy 1, or the square root of 5 over the square root of 5. So I'll have 2 square root of 5, and that's over our square root of 5 times the square root of 5, which is just going to be 5. There's our answer. And let's look at this last one here, or almost last one, sorry. So let's break this up. The square root of 7 over the square root of 2. All right, well, let's multiply by the square root of 2 over the square root of 2 to cancel out this irrational denominator. I'm not really concerned about the numerator, but it's going to be our help with our simplification here. So square root of 7 times the square root of 2, they're both under square root, so I just multiply the insides. And over the bottom, I get 2. And don't go ahead and simplify, because this is under a square root and this is not. So I can't simplify that any further, but I did get the radical out of the denominator. And then let's look at this last problem here. I don't know if I can scroll down any more. Let's lift this up. There we go. All right. If we look at this problem. I don't have a radical in the denominator, so why do I want to concentrate on changing this? Right now it looks kind of messy. What we're going to do is combine it to look like just one fraction. All right, so in order to do that, it's just like adding and subtracting fractions from the past. So if you have an integer plus a fraction, the easiest way is to make this into a fraction. And then look for common denominators. So if I wanted to create a common denominator, I say, well, what do 1 and 5 have as multiples? And the least common multiple of 1 and 5 is 5. So now when I go to rewrite the fraction, I would have to take a 1, multiply it by 5, so let's multiply this also by 5. This is like regular fractions. And then the second one, I didn't have to multiply by anything, so it remains the square root of 3 on top. So this fraction and that fraction are the same. And then the 2 over 1 became 10 over 5. And if we reduce that, we'd get 2. Same problem. A lot of times in math, we're not actually trying to change the problem. We're just trying to make it look different. And now, if we add the top, I have to keep 10 and the square root of 3 separate because that's not under a square root. And then I'll combine the denominator, so I'm only writing it once. So we have it just over 5. Do not add those. When we add fractions with like denominators, we don't add the denominator. And then this is our more simplified fraction.